Yeah. Hello there. Hopefully the stream's going. Yep. Switch to live chat. Yep. Got the message from the YouTube. Hopefully this one works. Yep. It kind of seems to. So yeah. Hey guys. Hi there. Um. Yeah. I just well decided to make a daily coding session to well yeah, make a daily coding session for yeah, to go with for you, because just why not. um I got like something of an hour or something. Yeah, so I think we could go with it. um yeah, so we're writing a decentralized storage in Rust. um Yes, so the last time, what we did the last time is, well, first of all, we created our primitives for a virtual file system without the chunks, obviously, because we're gonna store them in nodes. And I did, um, oops, run. I did something of can yesterday. I created, first of all, I created a certain chunk primitive with index, ID, size, and whatever to store it. Also, the IDs are now unsigned int, 128 bits, unsigned integer. I mean, that's the largest we could fit into the into single word on a 64-bit system. But it gives us kind of more guarantee that the ID is pretty much unique. So that's a way to go in the first place, and that's a good um, start. But I did an error. I did a mistake by projecting, well, just creating the core concept of a distributed file system. I did a mistake because unfortunately I had no experience, no, or I mean I had some, but it was more of a something small for university. Um, so the mistake I did is, as you can see, well, I have this directory entry, file system entry. I mean, file system entry, common interface for file entry, directory entry, and a symlink entry. That's basically everything we need, right? Um, at the point there I did is, well, I thought of it as if it were a file system in memory, just without the files themselves, which which is an error, because that would require an enormous overhead of well, that would require an enormous overhead of um, what was it again? Yeah, of um, locking it. We gotta implement locking mechanisms, right? We would have to implement all kind of pointers, because as you can see, there's this symlink entry which points to a certain entry, to a certain another entry, whether it's a file or a directory or another entry. We don't care. Which would basically require us to create a goddamn GraphDB. It would really require us indeed to create a GraphDB with ACID compliance and all around, and that would be just the kernel, the core. That would add enormous overhead, and it's not good. So for now, we're scrapping it. And there's much better approach I found, and guilty, I gotta admit. I looked up the ChatGPT just a bit, what it had to tell us, what it could tell me about a distributed file system, and yeah. So all the thing is basically key value storage. If you want to represent it, well, you do it with a key value. So let's just continue. Um, yeah. Just give me a second. So yep. First of all, file system node. We have to first of all, let's create a new folder. Just gonna call it well. Serialized. No, bullshit. Um, it's gonna be meta or something. Storage. Yeah, just gonna call it storage. We'll go with it. First things first. Um, uh, oops, sorry. Yeah. So yeah. Just create an inode and define a type ID, which is an unsent integer. Um, let's call it a what else do we got? Well, hash, obviously. A new data type. Um, and the most important, product inode. It's in the hash, and we don't need it. It's just the pub ID. It's the ID and the pub. No, ID pub target is an option. Nope. It's gonna be ID as well, and a kind of inode. That's everything we need for now. Inode kind. No, we don't need that actually. It's just a pure enum file, directories, and a symlink. That's basically everything we need for now. Then we have a we need a file. We need a file layout, right? information, which is a size. It's a hash. It's got a block size is the U size, I believe. What else? Look up. Chunks is the vector of chunk ref. We need a chunk reference. Chunk reference. No. We obviously. Oops, sorry. D. Got a chunk reference. Which is a public ID, which is an ID. Well, offset. Well, index. I mean, we could derive we could derive the offset from the index and block size. Hash, and the size itself. Yeah. TP size. Oh, it's not a block size. It's a chunk size. It's a file information. It's a file meta. Go this way. Is G somewhere? No. File meta. Then we create directory meta, which for some reason. Directory meta, which has certain amount of entries. Meta. No the file system node.